Good morning. All right, so we are starting investigation 3 today, which is going to seem hopefully very easy because I was so intense with you guys the past 2 weeks over Pythagorean Theorem. This is literally just going over everything we've already learned and just expanding on that. So this should be relatively review for you, but now we're going to go a little further. So in today's work, they're going to ask you guys to, use dot paper or grid paper. Honestly, just use your grid paper. And you feel free to put dots. I would use an entire page in your notes to do the work they're asking you to do. Now, you can use these 3 if you want. I encourage it because they want you guys to make 2 right triangles, 2 acute triangles, and 2 obtuse triangles. So I just did 1 of each for you, just to make sure you guys understand what you got to do and how you got to do it. First things first, you got to know what a right, acute, obtuse triangle are. Right up here, a right has 1 angle, that's a 90-degree angle, and that's it right there. And obtuse has 1 angle that's greater than 90 degrees, which means the other 2 angles are less than 90 degrees because they all add to 180 degrees. And an acute triangle means all angles are less than 90 degrees. Now I'm going to start over here because I want you to find the area of all the squares on all the legs. So here's how you would do it. I just chose this one at random size. Again, choose your own. Make them bigger or smaller, but you got to have 1 of each. So here's how we did it. Right angle, this one's pretty simple, and I've connected them. So now I got to find the area of all the squares. So the area of square on A, okay, area of square on B, and area of square on C. Now, this is gonna you'll be seeing how to do all these. I'll erase these as I put them up there, but you'll see how simple this is. For this first one, really simple. Well, this is easy. Let's call this A. Remember, the A and the B are the 2 smallest sides, okay? And it's hard to distinguish on an acute, but we'll get to that in a minute. So over here, where do we go? Okay, boom. This is a 2 by 2, so call that A. So the area on square A is 2 times 2, so that's 4. Area of this square is 1 by 1. So 1 times 1 equals 1. Now the area on C, here's how you do this. I got to find out what this length is right here. So remember, I can just make a right triangle out of this to figure this out. So I got to find the length. Once I know the length of 1, real quick, I also want you to notice before I go any further, I'm using my knowledge of perpendicular lines when I did this. I noticed here from this dot to this dot, I went up 2, left 1. Well, the perpendicular slope is the reciprocal opposite. Right, so if the slope is up 2, left 1, that's a slope of -2. So the perpendicular slope, and give yourself these notes just like this, the perpendicular slope to this is the reciprocal opposite, so that's 1/2. So I need to go up 1, right 2. That's how I pre-made all of these to figure out exactly where it goes. Now that I know that, I'm going to find this length. Once I know the length of one side, I know the length of all the sides. So I got a length of 1, 2. By 1, so 2 squared plus 1 squared equals C squared. Remember guys, the C is the longest side of the triangle. You guys are asking that question on the test on Friday. This is 4 plus 1 equals C squared, so I got radical 5 equals C, okay? Radical 5 equals the length of C. Now that we know all this, please pause this and take these notes if you'd like. I gotta save this room for the remainder of this lesson. Now that I know the length of this side is radical 5, I know that, well, it's radical 5 times radical 5, which equals 5. So there's the area of that side, okay? There's that. So feel free to do this on your grid paper. I encourage you guys writing right triangles in there so then you can find out what this length always is. Let's do the obtuse triangle next. Now, the way I drew this on my own is I just knew I needed one angle to be greater than 90. So again, I just made this obtuse and opened it up past 90 degrees, that right angle. So that's how I did that. And then I just connected this. Now, how do I know this square is perfect? These are 90-degree angles. How do I know this? Because to get from here to here, I went up 1, left 1. So in order to make sure I draw this accurately, that means I'm going to do the up 1, left 1. I'm going to do the opposite. I'm going to go down 1, left 1, so that I create, remember, up 1, right 1, or down 1, left 1. Creates that 90-degree angle. That's how I know these are all 90-degree angles. This one's pretty simple because it's straight. Over here, to get from here to here, I went up 1, left 1, 2, 3. So I go up the opposite. Reciprocal opposite would be -3. So I'm sorry. up 1, left 3, that's a negative 1/3. So then the perpendicular slope is positive 3 over 1. So 1, 2, 3, right 1. 1, 2, 3, right 1. That's how I knew I drew it accurately. Going forward, let's do A. Remember, this is my A, my B, and my C. It looks like belongs. This one's a little tricky, but we'll get to this in a second. Where am I at? Here we go. A. All right, now this A does not sit on a straight line. This is at an angle, right? So I got 1 by 1. So if I'm looking at this as a right angle right there, I got 1 by 1. So that's 1 squared plus 1 squared equals c squared. Well, this is 1 plus 1, which is 2. So we know c equals radical 2. Okay? Give yourself these little notes. This is what you got to do every time when it's not perfectly straight. So now I know the length of this square is a side length of radical 2. So again, you just do radical 2 times radical 2, which equals square root 4. Square root 4 is 2. So the answer is 2. All right? Square B. Let's call this our B. This is easy. Distance of 2. So 2 by 2 equals 4. And our C, again, you got to make that right triangle. All right, so that I can understand when I know one length, I know all lengths. So I got a leg of 1 and a leg of 1, 2, 3. So this is 1 squared plus 3 squared equals c squared. You know this is 1, this is 9, so this is 10 equals c squared. Square root both sides, so c equals radical 10. Now following suit, find my area. Radical 10 times radical 10 equals 10. Boom, just like that, okay? And I fill in my data. You're going to create a table and it'll tell you the instructions today to copy the table, fill in this up, and then you'll be answering basic questions based on the answers you get. Now for this one. This one's kind of tricky because this is an isosceles triangle. How do I know this is an isosceles triangle? Because both of these lengths appear to be the exact same. I did this by accident, but not a big deal. Because we know it's not a right triangle, do not worry about stressing about which one is the A, the B, or the C, because you can't, in this case, and this is going to happen sometimes, you can't determine what the C is for isosceles. So let's just, for the heck of it today, let's just call this the A and the B, let's call this the C. Even though we know this side length is the smallest, it doesn't make a difference because we know it's not right, so it doesn't matter at this point. So that said, we already done this before. This is a 1 by 1 right here. If I'm looking at this triangle right here, and I already know this length is square root 2 based on the work we did earlier on this one right down here. So it's the same side length. So this has a length of radical 2 times radical 2 equals 2 is my area. Over here we got to find the length of one of these because remember these both have the same triangle right here. The A and the B are both 2 by 1, so this one should be rather simple. 2 by 1 is 2 squared plus 1 squared equals c squared. 2, which is 4 plus 1, so c equals radical 5. So I know radical 5 times radical 5 is square root 25, which is 5. Same thing over here, square root 5 times square root 5 equals 5. Be back in a second with some more examples of what we're doing today. Okay, I'm going to leave this up for today's lesson, so when I see you guys in class, you'll see we're going to come back to this. Some other stuff you're going to be seeing today is just more going one step further with multiplying radicals, and then I'll be doing dividing radicals in 1 second. But you'll see some stuff like this in today's work as well, so I want you guys to know, don't get daunted, don't be scared by seeing parentheses and doing this stuff, because if I would have asked you guys to do 4 times 3x minus 5y, well, you would just distribute. You would multiply this by this, and this by this, and this would be 12x minus 20y, and you'd be done. Okay, well, doing the same thing, just follow the rules of radicals. All right, so here we go. I'm going to do my distributive property. I'm allowed to multiply what's on the outside and on the inside when doing this. So now this simplifies to radical 15 minus 2 radical 18. All right, you do 3 times 6. Oh, look at this. I know there's a 9 and a 2 inside of an 18. So the 9 comes out as a 3. So your final answer is going to be radical 15 minus 6. Radical 2. And this is simplified all the way down, just like that. One other example is just like this. Now I can do this one of two ways. I can simplify this first and then multiply it, or just go ahead and do all the work and see what you get. So I'm going to just do that. I'm going to multiply this by this and this by this. I'm going to get radical 40 minus radical 50. All right, well I know there is a 4 and a 10 inside of here, just like I know there is a 25 and a 2 inside of here. 4 comes outside as a 2 radical 10, minus 25 comes out as a minus 5 radical 2. And we are all done. That's how you do them. All right, last but not least, some other fraction work that you guys began working with last week, but we're going to really go into depth this week. Rules of radicals. You can't have a radical in the denominator. You can never have that because this simplifies to square root 6 over square root 3. Well, it's rather simple. This is how you solve, and this is how you simplify these ones all the way. You just simply multiply the radical out of the denominator, as you just learned over here. Radical times radical, the same one is going to be, in this case I'll do it down here. So now this is radical 18 over, well this makes square root 9, which is now 3. Perfect. Well guess what, we are not done yet. We are not done yet. Square root of 18 simplifies further, okay? I got a 9 and a 2. 9 comes outside as a 3, so now this says 3 radical 2 over 3. Well, guess what? This goes one step further. 3 over 3 ends up canceling, and your answer is radical 2. That's how this simplifies down. Doesn't that make sense? Because 6 divided by 3 is square root 2. Look at that. That's the way. I did the long way. The easy way is just divide them if you can right away. This one, again, let's go through it the long way because that's how it's going to eventually be with you guys as we go through this. So I just follow the basic rules. I know this becomes square root of 8 over square root of 6. Now, if you want to, before you multiply this out on top and bottom, you could simplify this if you'd like. I have no problem with that whatsoever. So keep the number small. 4 comes outside as a 2. This now says 2 radical 2 all over radical 6. Now multiply it out. Okay? Multiply top and bottom by radical 6. And you only multiply what's on the inside. So now this stays as 2 radical 12 over radical 6 times radical 6 is square root 36, which goes down to 6. Now, I can simplify what's on the outside in this before I simplify my radical 12, because I got two things going on. Yes, 2 over 6 does reduce to 1/3. You can go ahead and do that if you want right away. Fine with me. So this is 1/3, which is just the same as radical 12 over 3. All right, well, I cannot do square root of 12 divided by 3 because this is not under radical and this is under radical. But radical 12 does break up into a 4 and a 3. So now that I know that, the 4 comes outside as a 2. So this fully simplifies down to 2 radical 3 all over 3. And these numbers have nothing in common, so there's nothing to do there. And I cannot divide a radical 3 by a 3 because these are under and outside. So we are all finished. I will see you guys in class.